Hey, calculus teachers, let's do a couple other things with the freehand function tool in GeoGebra. So on the GeoGebra website, I'm going to go to the GeoGebra Classic link. And when it pops up, I have all these other things that I never really like to have open. So I'm going to close them and center up my axes and maybe make this window on the left-hand side a little bit larger. So the freehand tool is in the upper left-hand corner. So if I click on the move icon, I want to use the freehand shape. I'm just going to make a curve like this, and maybe right below it make somewhat of a sinusoidal shape. And then when I'm done, I'm going to put that tool away by pressing the escape key on my keypad. Now I don't need this 2D view anymore. I actually want to move to a 3D view. So if I can direct your attention to the upper right hand corner where those 3 pancakes are, if I click on those 3 pancakes and move down about 2/3 of the way to the view menu, if I click on the view menu, I can check on the 3D graphics view, and I can uncheck the graphics view, because the only thing I really want now is the 3D view. And then I'll go back to the upper right hand corner and click on those 3 pancakes to close that menu. And so this is looking pretty good. So in order for us to use these freehand curves in 3 dimensions, we need to turn both of them into curves, like parameterized curves. So what I'm going to do for each one, I'm going to use the curve command, if I can spell it correctly. The x coordinate is t, the y coordinate would be f of t, so this is going to be for my f of x function. And my z coordinate is 0, and t will let t range from -3 to 3. That should be plenty of room on my freehand curves. And let's do the same thing for g of x. So curve of t, g of t, and 0, and t will range from -3 to 3. Now let's fill in that space between those 2 curves. And so I want to fill that space in with a surface. And what I'll do is my surface will work like this. I'm going to go u times a of t plus 1 minus u times b of t. I want u to range from 0 to 1, and I want t to range from -3 to 3, just like those other functions did. And so this works out pretty well. Let me hide the gray XY plane. So if I can direct your attention to the upper right hand corner, not the 3 pancakes again, but right below that. And then I move all the way to the left hand side of that context menu, if you will. If I click on that, and I want to click on the axes with no gray behind them, and that will hide that for me. And then I can click on that and close it. So we're a little more than 3 minutes in, and so we've got that. Let's rotate that surface we created, that surface between the 2 curves, let's rotate that around the x-axis. I would like to create a slider that will do that for me. So I'm going to go n is the name of my slider, equals, and I'm going to pick a random degree measure. Let's go 50 deg for degrees, and when I click on enter, GeoGebra knows, hey, you must want a degree slider. And so I just want to rotate that surface, which is C, I want to rotate it using slider N around the x-axis. And that is pretty nice. So that's 50 degrees around. And as I move that slider, that works pretty good. Now let's take the curves we created, curve A and B, and let's create rotated surfaces out of those. So that's the surface command. So surface, we want to take curve A and rotate it using slider N around the x-axis. It's not bad. And let's do the same thing for curve B. We want to create a surface using curve B rotated by slider N around the x-axis. Not bad, kids. Not bad. So freehand functions to solids of revolution between 2 curves, all done in less than 5 minutes.